Right. This problem completed now? Yes, to the next one. Take it. Not two monkeys are there. Hmm. Plant. Take it.
This week, many months are history for Independence Day, Lakshmi Vratam, Rakshabandhan. 7 to 8 months are
Take it. Okay.
Rakshabandhan, Independence Day.
Hey, Dixit. What? To the next problem. Find the tension in upper part of the string and in the middle part of the string in the following figure. Here we have the two monkeys are there. Hmm. So here. Now two accelerations are there. Now we need to find both T1, T2, we need to calculate. Same string only. Same string only. So the two monkeys are hanging to the same string, one over other. And the two monkeys are moving with some acceleration. Now let's see now here. First we always talk about the below monkey first thing. We should not talk the upper one. We should find the below one. Lowest one we need to start always. Okay, so first monkey. So this means okay, this is the first monkey and this second monkey. Now we need to start the second monkey, we need to start always. So let's start the second monkey now. So tell me now here. What is the weight of this second monkey now? Tell me now. Weight of this monkey. So this is 40. And this monkey, this acceleration given. So tension we can call this a T2 now. And this monkey moving which direction? Upward direction. So that means this acceleration which is given as A2. Yes, so we can write the equation first. Write the equation now. A2 which is equal to what? Tell me now. T2 minus 40 by mass of this monkey. How much now? 4 kg. And A2 given now how much? Yeah, so then we can get the T2 now. T2 will come it as 12 plus 40, 52 newtons. This is the tension caused by the second monkey. Now we'll talk about the first monkey now here. Now you see this thing, first monkey, what are the forces acting now? So first weight of this monkey downward direction, first monkey, how much this weight is in? 60 newtons. Next we have a tension is there. How much this tension now? T1. And this monkey moving which direction? Upward direction with some acceleration A1 given. And what are the other forces are acting? T2 is downwards. Okay. Now the T2 will act downwards. Understood this point? So to get the T1, T2 is required. That's why we find the T2 first. Right. Now write the equation now. Now, so we can write the equation A1. A1 equal to what? Tell me now here. T1 minus T2 minus 60. by weight of this monkey. How much now? That is 6. A1 value given 5 now. So this means 5 into 6, 30, which is equal to T1 value we need to get, and T2 is 52 minus 60. So that means T1 value how much now? So this 30 plus, yes, 52 plus 60. Yeah, T1 is 142 newtons. Okay. So this is here you need to understand when you're talking about this as a upper monkey. So this T2. So for this first monkey, T2 is upwards. This second monkey. But for second monkey, we need to see this direction, first monkey. You need to understand this point is a crucial here. Here for this monkey, tension upward directions. But when you're talking with respect to this monkey, now the tension is what direction? This direction. Okay. Next. See what they're saying here. When 5 kg block leave the floor. Just imagine now here you have this simple balance is there now. Weighing machine like this. Now here, so in one side, so 10 kg, other side 5 kg we have. They both are in on the surface now. Now here we are applying a force we apply now. We apply the 1 Newton, 2 Newtons, we'll keep on applying here. If we apply sufficient of force, then only this pan will move up. Yes or no? Now that's what they asked me to find. At what time they will move? Okay, now you tell me now here 5 kg block leave the surface. Now here how much the weight of this 5 kg block is a 50 newtons, right? Now here we have a tension is there. Now tell me now T. So this is also tension T. Okay, now if this is T, this is T. Next, what is the tension here? And what the tension here? How much the tension now? T na. How much the tension here? 2T. Same thing. This is the tension 2T. Now you tell me now here. So for this block has to move. So we need to apply the minimum upward force will be 50. So here, so this means this minimum value must be how much this value? Tell me now. If the T value must be minimum 50, then only it will move up. Yes or no? So that means for the 5 kg block to move up, the value of T must be how much now? 50 newtons. Understood this point? Tell me. If this is 50, now look at now here. Here we apply the how much the force we applied? 2T we applied. And here is how much now? This is F now. That means 2T, which is equal to F. And this is 2T. T value how much we have a 50. And F is how much now? 20 into T now. F given 20, T given. So from this 0, 0 will get cancelled. How much the T value? Tell me now here. 2 also will get cancelled. That is 5 seconds. That means here what happening now you need to understand. So after 5 seconds, now here this force we applied now. This force is a variable force you need to understand here. Look at now. Now if we say how much the force we applied here, F value, this is a 20 into T. Now at T is equal to 0 seconds. How much the force value? 0. Yes, now T is equal to 1 second. How much the force you tell me now? That is 20. And at T is equal to 2 seconds. Now, how much is F value? This is 40. Like this, we're happening. Now, when T is equal to 5 seconds, like this, how much the force we applied? You tell me now. 100 newtons. When you apply the 100 newtons, this here we apply the 100. Middle you apply 100. So then 50 will go to here. 50 will go to here now. Isn't it? So that means when you, which one? That's why the 10 kg, this fan doesn't move up. Only this will move up, na? Okay, so that means this 10 kg block. So here, for to lift the 10 kg block, we need a more force we required. That is 100. T value must be 100. Then only it will move. Okay. Now, when you apply this as 100 newtons, F here, 50 will be applicable here on this string, this side. Another 50 here, na. Now, this 50, this is sufficient to lift this block. That's why 5 kg block is moving upward direction. But this 10 kg block doesn't move. Just imagine now we have taken the pan, we have taken now one side we have 5 kg, other side we applied, this is 10 kg we applied, and you are trying to lift it now. When you apply this certain amount of force, the 5 kg will move up. But 10 kg doesn't move, na? Why? Because you need to supply the sufficient amount of force. Understood this thing? Right? Now let's see the next problem. They're asking time only, na? When it is move up. So when now here at 5 seconds, t is equal to 5 seconds, this 5 kg block will move up. Right? Take the next part down. Now you tell. Now look at in this case. And what they are saying here. Now 10 kg we need to do. Find the here what they are asking. Read the problem carefully first. Acceleration of which block? 5 kg block. When? 10 kg. 10 kg is move, leave the floor. Means when for the 10 kg has to leave the floor, how much force we need to apply, we need to find first. Okay, so when this is moving, so here 10 kg block is moving means, so 5 kg block previously only will move up, na? Isn't it? Now this is when the 10 kg block is moving, just leaving, the 5 kg block will move with some acceleration. That acceleration we need to find out. Yeah, tell me now here in this case, what is this weight you tell me here? How much here? This is 100 newtons. If we call this is the tension T, so this is also same tension at T. Now tell me now, for the 10 kg block has to move up, how much the T must be? What is the minimum value of T? To move up, what is the minimum value of T must be equal to 100. T value. So the tension I'm asking the tension I'm asking. How much the minimum value of tension? Yes, for 10 kg block, for 10 kg block to leave the floor, minimum worst case we need to see. So this is, we can say this as so this is 100.000001 is sufficient. This is almost taken as 100. Okay, just very small value more than 100 is sufficient. Okay, strictly speaking, just a small greater than 100. Okay, so we are taking the nearest integer we have considered as 100. for 10 kg block to leave the floor. Yes, tell me now. So here T must be how much, you tell me now here. T must be 100 newtons. Yes or no, this point clear? Now if this is T, now you tell me now here. So this tension both are same only. Now that means how much this value, tell me here, this is 100. Now what is the weight of this 5 kg now? That is 50 newtons. Now you tell me now here. So this means this 5 kg block will move upward direction or not? So then we have certain acceleration now. How much is acceleration, you tell me now? Let the acceleration equation. Which direction acceleration? Yes, T minus 50 by 5. So how much the T value? 100 minus 50 by 5. So that means A is equal to how much now? 50 by 5. That is 10 meter per second square. Understood now? In the same problem, if I ask when the 10 kg block leave the floor, then what the time? At what time 10 kg block will leave the floor? So 10 kg block, when it will leave the floor now here? This is T, this is T. So here we have a 2T now. So that means what we can say now, this is 2T, which is equal to 20 into T now. And T value we got how much? 100. And which is equal to 20T. Then how much the T value now? 10 seconds. Okay. Time. Yes, one more problem similar to this. Take this thing. The already time tensions already marked in the problem itself. Find the time when 5 kg 15T. F is equal to 15T. 5 kg block lift off.
Five kg. Pulley. 15 minutes.
5 kg block, we have to lift it. Now here, 5 kg block, this has to lift now. This minimum value of tension must be how much? So this T must be equal to 50. First thing clear now? Now here here we have a tension, we have a T. This we have tension T. Here we have tension T. How many T's? 3 T's. So that means how much this value, tell me now. This is 3T. Okay. Now that means what we can say now, 3T equal to 15T now. So this is 3 into T value, how much now? 50. Equal to 15 into small t. Then how much the time value, tell me now here? Yes, which is 10 seconds. Okay. Yeah, so that time only, na? Not asking. They are asking only time only, na? Yeah, no, here this is 5 kg block just moves. That means what, tell me, acceleration 0. It is just moving. We apply. So you can see now here this value is how much now? This is tension 50. Then how much the acceleration if we write? That is 50 minus 50, isn't it? That will come it as 0. Okay. Then next. Take this. What should be the minimum acceleration of monkey so that block lift off the ground? Yes, what will be the minimum acceleration they're asking, not the tension, yeah? Acceleration so that block will move, just will move the surface. How much the tension? 100. The based upon tension, we should find that. That's it. Same string now. So tension is same. Hmm. How much the tension? Tell me. First of all, so here this weight is how much now? 100. Yes. Now for the 10 kg block just to move, what should the minimum tension must be? Yes, tension must be 100. So look at now, this is same string only na. The same string. So that means this T also, this tension is also must be 100 only na. No, same thing. Tell me now here. So tell me now, weight of this monkey. How much this value weight of the monkey is? Yes, 50 newtons. And we have tension. So tension T. So the monkey has to move which direction now? Up or down? Up they given now. So write the acceleration. Yes, so T is equal to what, tell me now? T minus 50 by 5. So T value we have now how much? 100 minus 50 by 5. So A value is how much now? 10. Okay. Then this complete chapter police only. You can ask. See this thing here, this Pulley problem. The intermediate student will struggle a lot. You can ask them. How the Pulley problems in class you used to feel? Direction of forces. We have. So we will complete very forward. Also, but your father sent a syllabus also. Complete syllabus it is there. So yeah, you can ask whether he's in he's already completed. Work power energy also started, I think. Uh, friction is there. So then you tell me now here how the students face difficulty in the Pulley problems. Yeah, so you can ask. So many other student, yeah, you told you now, they don't know right to the acceleration equation. They don't know.
Physics.
Huh?
Physics listeners.
So the situations are like that.
3
Uh,
above 40. Above 30. You said physics average is
-2 average. Things that happens like that. So many students doesn't know. So basically the thing is when the student will stop the doing physics, the moment the straight line which started the differentiation integrations now. From that topic on, they'll stop doing the physics. Before that, so they will do motion under gravity, average velocity, all those topics they will do. Every student will do. And integration will come, they'll stop doing the physics. And vectors will come, they never touch after the vectors. After vector concept, then no student will do the physics next that time onwards. Yeah, you can ask her. They'll know, isn't it? So vectors, the moment you heard a vector, they are that time onwards. So the student doesn't do any physics. They won't see in the exam paper also, they won't see in physics.
Integration.
Then they stop that day onwards. This all
integration differentiation introduction దాని తర్వాత units and measurements.
So units and measurements should not start in the first of all. So that is it will contain the all first year formula, second year formula. Units without knowing what is what, then how will you know the unit of that system, that quantity? You have acceleration. You know acceleration. There after knowing the acceleration, you know the acceleration unit. Acceleration. So how will you know without knowing force? You don't know what is the force, but you need to know the units are the force. Energy. There are so many terms. The moment of inertia, specific gravity. There are so many. Nearly totally 500 terms are there. 500 formulas. Those 500 things you have to by heart things. If you know what is acceleration, now you know understand the things. From that you develop the formula. Units you know. So acceleration equal to rate of change of velocity. Velocity means meters by second. So that's why meters per second square. Like that one you will get. But without knowing, so then if you starting only they will get so remember acceleration units are meter per second square. Will you able to remember? Right. So take the next one. A small break for the pulleys, and thereafter we'll continue. Commercial break for the pulleys. Take this one. They given us some rod, they given, just imagine, and we applied some forces applied. They are asking to find the tension, the midpoint they are asking to find. So first we'll find the acceleration. So here just imagine now this is the block. Now here this block at one end. So we holded this thing, we applied some force we applied for this rod. So we'll find the acceleration of the block. You tell me first. How much the acceleration of this rod? So this is force is 100. Acceleration equal to net force by total mass. How much the force we applied? 10. Yes, mass. Mass is 10 kg. That means how much you tell me now? 10 meter per second square. Got it first? Now, where they ask him to find the tension now, tell me. At the midpoint, is the rod has a mass or no mass? Mass is there. So that's why what I can do at the midpoint they ask me to find now. Now I'm treating this as, just imagine now this is the combination of two blocks where imagine this is one block and this is one block. Okay, so this is this midpoint. This part I'm calling as one block. This part I'm calling it as second block. So what is the mass of this block? That is 5 kg. Okay, and mass of this block 5 kg, isn't it? Equally divided now. And just imagine now these two are connected by a massless string. Imagine a very massless string we have connected. Now you tell me now we applied the force we applied. How much the force we applied? 100 newtons we applied. Now this system moving with some acceleration now. With how much acceleration is moving now? 10 meter per second square. Now this type of problem we have seen earlier. Two blocks are connected we have seen. So tell me now what we can say now here. So then what is the force taken by this fellow? This fellow m into a na. It will take how much now? M into a. How much is force now? M is 5, a is 10. How much it will take? 50 will take na. Now we applied 100, you applied. 50 will be taken by this fellow. Then how much left out now here? So then that fellow will be given to this fellow. So this is tension is how much you tell me now? 100 minus 50, that is equal to 50 newtons. Okay. The same, or we have two blocks, three blocks connected, we have seen. The same thing we will convert like that. Length of the rod. Length is given now. Length is given, so it is total. When the total length is at 20 meters, that mass is how much now? 10 kg. So at the midpoint means what we can say now? 10, 10 we can treat now. That mass is 5 kg, 5 kg.
So length is not needed.
Yeah, midpoint means length is. So sometimes they'll ask some other location. And let us say in the same problem, if they ask him to find, so this given this, now they ask him to find here what is the tension they are asking. Let us say this is the 2 meters. Now let us say now take this problem, the second problem. They ask him to find the at a 2 meters from C, they ask him to find the tension. Now what we'll do? In this case, length is required. Tell me what we can do in this case. The same problem. So find the tension. So this is the block is given. 2 kg we are considered now. Yeah, so this is total, which is equal to how much you tell me now? 20 meters. Total 20 meters. Okay, 20 meters. Now we have taken 2 meters. We have taken this side. Here we applied the force. How much force we applied here? Let us say 100 newtons we applied. So at this point, let us say this point we have calling it as A. And this distance, imagine now they given as a 2 meters. They ask him to find the tension at 2 meters. Understand the problem? Okay. So now here, let us say this is my rod now here. 20 meters. Now we apply some force we are applying here. I'm asking the force at this location. Okay, now first we will find the acceleration of the block. What is the acceleration? Tell me.
100.
So this acceleration, which is equal to what? Tell me now. Yes, so 100 by, yes, total mass is 10 kg. Okay, 10 kg. So this is 100 by 10, which will be equal to 10 meter per second square. This thing clear now? First thing. Now what we should do here? Now this is 2 meters. This is 18 meters. Okay, this part is 2 meters now. Remaining is how much? 18 meters. Now we can treat that also as a 2 blocks now. Okay. Now so this is now we can imagine now these two are connected by a massless string. Then how much the force we applied here? This force which we applied as 100 newtons we applied now, and this system which is moving with some acceleration. How much you tell me now? 10 meter per second square. Yeah, you tell me now. Now we need to find the mass of these blocks. We have to find. Okay, tell me now mass of these blocks. Now look at now when this is a when the 20 meters is the length. So how much the mass you tell me? 10 kg we have the mass. Now when we have this length is 2 meters now. When the 2 meters is there, then we need to find the mass we have to find or not? Yes, tell me how much is mass now here? 1 kg. I think you know cross multiply, you do it now. So this mass, if I call this mass is simply M1 if I call. So simply cross multiply now. Yes, this multiply and this you multiply. So this is 20 into M1 which is equal to 20 now. So that means M1 value how much now? Yes, M1 is 1 kg. This mass is 1 kg. So this mass is how much now? 9. Ah,
So from 20 subtracted to 18 is to 2 we are getting this ratio. 9 is to 100. So mass also in 9 is to 1 comes to 9 kg 1 kg.
yes, that is also correct one. The proportionate manner. The ratio and proportion you might be known now. The same thing we do. The same thing that also. Now you tell me how much the tension here. So this block will take how much now? Yes, now M into A. M is 1, A value 10. So this is 10 newtons now. And so that means how much the tension here? That is 90 newtons. Okay. Like that they may ask anywhere they will ask. Some other location also they may ask. So the same manner will proceed this type of problems. Then yes, now tell me now. Ah, resolve. First resolve it. Resolve the forces now. Here the 20 newtons is there. Now this 2 kg and this rod, these two are together fixed. They are connected. Now tell me now here, how much the force, effective force you tell me here? How much is force you tell me now this one? This angle 60 now. So this is what tell me now? 20 cos 60. And then this is how much? Ah,
20 sin.
yes, so this is 20 sine 60. Right, so this value 20 cos 60 means how much this value 10 newtons now? And this value how much now? 10 root 3? Right. Now this block will move horizontally, only they will move. It cannot move upward direction now. So that means now we need to see how much now the whole thing I can treat as effectively as what you tell me now here. I can treat as single block only now. And can you tell me the acceleration of this block now? And what is the acceleration of this block? You tell me now whole system I can say. This is a single block I can treat now. And how much the force we are applying here? 10 newtons we are applying here. So what is the mass of this block now? The whole together we are treating a single block. So this will be equal to 5. So then this is one block. So this is 2 kg and this is 3 kg. Right. Tell me the acceleration of the system now. How much the acceleration now? So that is acceleration formula. How much? So this 10 root 3 does not contribute for the force now. So this is only this fellow will contribute now. Yes, so that is how much now? 10 by 5. So how much this value? 2 meter per second square. Now what they asking to find? Tension at the midpoint of the rod. Okay, so that means what I need to treat now here. So we should treat this also two blocks we need to treat now exactly same as earlier. So now these two are connected by some string, massless string. You tell me now what is the mass? The total mass of the rod is how much? 3 kg. Now this midpoint means this is 1.5 kg na? And this mass, huh? How much is mass? This 2 kg is there na? This, so this is how much is value? 3.5 kg now. Okay. Now we are applying the force we applied. How much the force we applied here? 10 newtons. And the system moving this direction with some acceleration na? How much acceleration? Yes, now here this 3.5 block will take some force na? How much the force this block will take? This block M into A will take now. How much now? 7 newtons will be taken by this fellow. If it is 7 newtons, then how much will be the tension here now? So this will be equal to 3 newtons. 10 minus 7 na, so 3 newtons. Right. Next, spring force. Spring force. Let's understand the spring now, spring force. Now, let's see now, spring force means what? So let us consider we have taken a spring and this spring one end is connected. One end is connected to this side, let us say. So this is, we have the spring like this. Right. Like this. Now here, so when we don't apply any force, the spring is just connected to one side. Just imagine One side we have connected, but there is no force is applied. No force is applied, then the spring will have some length now, and this length I'm calling it as L, where this L is called as a natural length. What is called as a natural length of the spring. So what the length of the spring when there is no force is applied, that is called as the natural length of the spring. And the every spring will have a one parameter that is called as a K, where K is called as spring constant. K is called as what? Spring constant. Spring constant, or it is also called as stiffness constant. We'll call it as spring constant, we'll call. So here you might be seeing springs, we have a small spring and we have heavy springs also we have. Now in our pens we have springs are there now, those are very thin. So when you apply the little amount of force, it can able to get deformed. Elongation or compression will happen. So in a bikes we have shock absorbers are the springs, and lorries also will have a shock absorber springs. Those are heavy. That means those springs will have high spring constant. Okay, so based upon the stiffness, whether it is a very strong or not, we can decide based upon the spring constant. The spring constant is high, mean that is a very strong. To deform, to change, we require the more amount of external force is required. Right? Where K is called as a spring constant, L is called as a natural length of the spring. Now, consider we have taken the spring, same spring. Now, this spring we applied certain force we applied. Let us say now we applied some force. Now when we apply now, the gap between the rings will be decreases. So this means we applied some force this direction. I hold it, we apply the force like this. Now this force which we used to call as the external, this is called as a external force. When we apply the force now here, so this is from here to here, this is the natural length. This is the L, that is the original length of the spring. And because of this application of force, now the spring will be get elongated this much. Let us say this is X, where this X is called as an elongation of the spring. Now, when we apply the force, you might be observed here, when you folded this thing, you apply some force we applied. That means what happens now, your hands will feel certain amount of opposition. The spring try to want to be get to the original position, isn't it? So there is certain force is developed inside the spring. Yes, some force will be developed inside the spring. That force is opposite to the elongation. Yes, that opposite to X. So the elongation is like this now. The spring is elongated right side. Then we have the some spring force will be developed like this left side. This is called as a spring force. Okay. Now this same spring now here, if we are trying to compress it, now tell me what happens. When you are trying to compress the spring, so we have taken the spring, we have taken. Now you are trying to compress the spring. Yes, now the spring get compressed like this. Right, now you tell me now, that means in this case we apply the force on the spring this direction. This is the external force we applied. Now the spring get compressed by this much distance now. This is the compression of the spring. Now in this case, now you just imagine now here, when you try to press the spring, your hand will feel certain amount of force opposite to the movement of the spring, isn't it? So that means in this case, which direction we have a spring force, you tell me now here. So this is this direction. Now this is the spring force. And here the elongation compression is this direction, but the spring force is opposite to compression. Here you see this thing, spring force is opposite to elongation or compression. Okay. So this is spring force is always, this force is developed. The force developed inside the spring to oppose the compression or elongation is called as a spring force. Okay. Copy it? Yes. Now, how much the spring force will be developed, that we are going to see now. How much force will be developed inside the spring? And that analysis was given by one scientist, which is called as a Hooks. Yeah, that is, huh? Hooks law. Right. Right, Hooks law. And what the Hooks law is the spring force developed, which is directly proportional to the elongation or compression. Spring force is directly proportional to the elongation or compression. And how that spring force is opposite to elongation, opposite to compression also. That's why we are indicating with a minus sign. Spring force is proportional to minus x. Minus indicate what, tell me? Spring force is opposite to the elongation or compression. Now we are using a proportionality constant. That proportionality constant which is given as what, tell me now? Kx. Fs is equal to Kx. Where K is what, tell me now? Spring constant. K is the spring constant. X is the elongation. Now, F is the spring force. Now, if we draw this graph between this elongation versus spring force, X and the spring force, and here the slope is a negative slope now. So this graph is a straight line that passing to the origin which lies in the second and fourth coordinate. Second and fourth coordinates. It will lies in the second and fourth coordinate. Look at now, f is equal to minus k into x. The slope of this graph is nothing but minus k. That's why it will lie in the second and fourth. Right. Now, let's see some of the points about the spring force. Hmm? Now you tell me now here we have a spring is there. Just imagine now. We have the spring is there. Yes, we have spring is we have placed now here. So both ends are free ends. That means these are not connected. Both ends are free ends. These are simply not connected. This end is this end, both are free ends. Now we apply, I holded this one end, we applied some force now here. We applied some external force we applied. Now you tell me now what the elongation. So here, now you tell me now this the spring is there. The spring we have placed like this now. Now we applied some force now, then what happens? The spring will move like this. Well, do you find any elongation of the spring? When you will find the elongation, now this one end is fixed, connected. Other than apply force, then only we have elongation. Right? If it is simply placed like this, we don't have connected to this end. Now I am applying force now. This simply will move like this. None. In that case, there is no spring force. Okay. So in this case, how much the elongation of spring you tell me now? 0. Then what the spring force now in this case? 0. When we have spring force is developed, if there is an elongation or compression is there, then only we have spring force will develop. If there is no elongation, there is no compression, spring force is 0. Okay. Now, now you tell me now here in this case. Now, so here this end we applied some force we applied. Let us say we have certain elongation we have. This is something X. In this case, how much the spring force you tell me now? The spring constant is K. How much the spring force you tell me now, which will be equal to minus Kx. Right. Now, let us say one more case. Now, in this direction, we applied some force. In this direction also, we applied some force now here. Yes, same equal force we applied. So, the applied forces like this now. Then, do you have any elongation in the spring? Yes, now we have, let us say here, in this direction, we have this one. Even the different force also, no problem. In this direction, we have elongation x1. In this direction, we have elongation is x2. Now you tell me spring force now here. So what is so spring force which will be equal to how much we can say minus k into total elongation is how much? X1 plus x2. Total elongation is x1 and x2 now. That is x1 plus x2. Right. If the spring is ideal, that means no mass. The spring force will be same everywhere. Like we have to talk about string. The string is ideal. That means no mass. Tension at every point is same only now. Like that. Like in case of a string, we should talk about the tension. For the spring, we'll talk about the spring force. That is only the difference. For in case of a string, what we can say now, we'll talk about the tension. And for the spring we used to talk about the spring force. Exactly, the properties are both are same only, but the terminology we use slight different. We are using the names as like that. And for any spring, spring constant is K and the length is L. The spring constant, so K, is inversely proportional to length of the spring. K is proportional to 1 by L. So we can write it as what L, K into L is constant, remember. The product remains constant. These are inversely proportional. Right.